Let's talk about units of measure. Technologists often use a variety of metrics, and as an IT professional, it is essential to understand the standard measures employed for storage, network throughput, processing, and speed. You need to know how to compare these metrics and to determine the most significant, smallest, fastest, and slowest values. In this video, you'll learn everything you need to know about the following topics: storage units, throughput units, and processing speed. As you learned earlier, computers work with binary data, meaning that data is stored as simply ones and zeros. Computers can efficiently utilize this binary format to store data on a disk, retain it in memory, or transmit over a network. Let's talk a little bit about how this actually works. Earlier, we explained that the basic unit of storage in any computer system is a bit. A bit is a single value that can be either 1 or 0. The combination of 8 bits is known as a byte, and a byte can store a single character or a small amount of text. Many of the files that we store contain thousands, millions, billions, or even trillions of bytes. Instead of using used numbers, we use larger units to help measure the size of stored data. You may already be familiar with the concept from the metric system. Instead of referring to a distance of 1,000 meters, we can refer to the same distance as 1 kilometer. Data storage units use the same prefixes to denote multiples of bytes. Be familiar with the standard multiple of bytes. Measuring data throughput. We use bytes to measure the amount of data stored in memory on a hard disk or in another location where data is at rest. When data isn't at rest, it is in motion, being sent over a network. Networks don't store data, so it doesn't make sense to describe network capacity in terms of how much data a network can store. Networks transfer data, so we measure network capacity in terms of the speed at which a network can transfer data. The speed measures the amount of data in bits. That's a network that can transfer in a given unit of time, such as seconds. This provides us with the measure that we commonly use for network throughput, bits per second, BPS. When we write BPS, bits per second, we use lowercase b's when measuring storage capacity. In kilobytes, megabytes, and so on, we use a capital B. That's a significant difference because the lowercase b represents bits, whereas the uppercase B represents bytes. Remember that 1 byte is equal to 8 bits. So if you wanted to see how many bytes a network could move per second, you have to divide the number of bits per second by 8. After you perform the division by 8, you get a less commonly used unit of bits per second, or BPS, multiple BPS. Modern networks can move data very quickly, so we no longer measure their speed in bits per second. Instead, we use multiples similar to those used for data storage. These units are bits per second, not bytes per second. Your home internet connection is probably measured in megabits per second. In contrast, your workplace connection is likely measured in gigabits per second. You'll only see terabytes per second on a highly high-speed network inside a data center. We don't yet include petabytes per second at this time because no network can transfer data at that speed. You'll often hear several different terms used to describe these measures of a network capacity. Network speed, throughput, and capacity and bandwidth are all very similar terms. The difference between them is that network bandwidth and capacity refer to the amount of data that you are supposed to be able to send on a network, and network throughput and speed refer to the amount that you actually do send on a network. They are all measured using these units of bits per second. Now, measuring process speed. We also need to measure how fast a computer can process data, which essentially describes how quickly the computer can perform calculations. Later, we'll discuss the computer's central processing unit. That is a central processing unit of the computer that performs the calculations. CPUs have internal clocks that measure the speed at which they can perform a single mathematical operation. Now, this isn't a clock like you or me might have in our home that ticks every second. Computers think extremely fast. Their internal clocks tick billions of times per second. We measure the speed of a CPU based on how fast the clock ticks, and we can count those ticks using a unit called hertz, where each hertz is a single click or a single tick. If you think about the clock in your home, you know that it ticks once per second. That clock is a 1 hertz clock. 1 click per second is 1 hertz. We measure computer clocks in multiples of hertz. Early personal computers measured clock speed in megahertz, which is equivalent to billions of ticks per second. Modern computer processors operate in gigahertz, which is equivalent to billions of cycles per second. We refer to each of those ticks of the computer clock as one cycle, a cycle. So, this wraps up the 3 basic ways we measure speed and capacity of data, networks, and computers. We measure data storage on disk and in memory using bits and bytes. We measure network speed in bits per second, and we measure computer processing speed in hertz. Thank you very much.